For this video, we're going to review some old ways of factoring as well as learn a new way of factoring. So to begin with, we always start by looking for a GCF. Your GCF is your greatest common factor, so it's the biggest number that goes into all of the numbers, and then it's the biggest variable. So to find the variable, we always use a variable with the smallest exponent. Okay, so to start with our first example, I've got a 6, 8, 12, and 4. So always start with your smallest one. And 4 goes into 12 and 8, but not 6. So it's got to be smaller than 4. And so it would be 2. 2 goes into all of these. So I'm going to put a 2 on the outside. Then I'm going to look at my variables. I have x squared, x to the 6, and x. So x is my smallest. So that's got to be my GCF. And then y squared, y cubed. So y is my smallest. So that's my GCF. So my GCF is 2xy. Then I'm just going to divide by that to figure out what is left in my parentheses. So 6 divided by 2 is 3. X squared divided by x is just x. Y squared divided by y is just y. 8 divided by 2 is 4. X squared divided by x is x. Y divided by y cancels. Negative 12 divided by 2 is negative 6. X to the 6 divided by x is x to the 5th. Y divided by y cancels. And negative 4 divided by 2 is negative 2. X divided by x cancels, and y cubed divided by y becomes y squared. And you can always double check there's nothing left in common with my numbers, as well as they don't all have x's and they don't all have y's. There's nothing else I could have taken out. And for the second example, I've got 20, 15, 12, 40, and 10. So again, start with the smallest one. 10 goes into everything except for 15 and 12, and so my only factors of 10 are 5 and 2. Well, 5 goes into 15, but not 12, and 2 goes into 12, but not 15. So there's not a GCF with my numbers, my coefficients. So there's not a number I can take out, but I can take out variables. They all have A's, they all have B's. So my smallest A is A squared, and my smallest B is just B. So the 20 stays the same, and then my A squared cancels, and B squared divided by B is B. And then the minus 15 stays the same. My a squares cancel and my b cancels. The negative 12 stays the same. A to the 6 divided by a squared is a to the 4th. And then my b's cancel. Then I have minus 40. A squareds cancel. B cubed divided by b is b squared. And then my 10 stays the same. And my a squareds cancel. B to the 6 divided by b is b to the 5th. Again, my numbers have nothing in common. And they don't all have a variable. So that means there's nothing else I can take out. Difference of squares. You got to first have subtraction, and you have to have perfect squares. And then it's just a pattern of a plus b, a minus b. Okay, always look for a GCF first. So if we look at the first example, 2 and 50 aren't perfect squares, but I can take out a 2. And if I take out a 2, I get x squared minus 25. Now I have perfect squares. So that 2 stays part of my answer, and then the square root of x squared is x, and the square root of 25 is 5. So I have an x plus 5 and an x minus 5. For this example, I don't have a GCF, and m to the 4th even exponent means it's a perfect square, and 1's a perfect square. So the square root of m to the 4th is m squared, square root of 1 is 1. Always cut your exponent in half when you take in the square root. So I have m squared plus 1, m squared minus 1. But always look to see if we can keep going. I have a subtraction over here with perfect squares again. So the square root of m squared is m. Square root of 1 is 1. Bring down my first parentheses. That's still part of my answer. And then I have an m plus 1 and minus 1. Always look to see if you can keep going to get as simple as you can. Groupings, when we have 4 terms, right? And we're always just going to cut in half. Still look for a GCF first. Because of this 1x, I don't have a GCF in the first one, so I'm just going to cut it in half. My GCF of the left side is 4x squared, and if I take out 4x squared, that leaves me with x plus 2. And then over here, I have nothing in common, so I'm just going to put a plus 1, and that stays x plus 2. You have to have the same parentheses, so if you do, you're on the right track. If not, you have to change something, and that's part of my answer. Then I have 4x squared plus 1. Again, look to see if you can keep going. If this was a subtraction sign, I could do difference of squares again. It's not, so I'm done, but always look to see if you can keep going. For number 2, I don't have a GCF. That 2 and 3 messes it up for me, so I'm going to cut it in half. My GCF of the left side is 3a squared, and that's going to leave me with a minus 2. And on this side, my GCF is 2. And that's going to leave me with A minus 2. Again, my parentheses are the same, so that's one of my answers. And then whatever's left, the 3A squared plus 2, is my other parentheses. Again, double check. There's nothing else I can do to simplify, so that's going to be my final answer. Then we look at trinomials. So we have A equals 1 and A is greater than 1. So these A equals 1 means that there's nothing out front, right? So these are what we call the plain Jane trinomials. Okay, now for the first one, there is a negative out front. So technically A is not 1, it's negative 1. But that's not that big of a deal because I can easily just take out a negative 1 from everything. So if I put a negative 1 out front, all I do is change the sign. So I have x squared minus 2x minus 15. Now I have a plain Jane trinomial. I just have to remember to keep that negative 1 out front. So to do a plain Jane trinomial, we have to multiply to C, add to B. So to multiply to negative 15 and get to negative 2, I know I'm going to have to use 3 and 5. So I'm going to have a 3 in a parentheses and a 5 in a parentheses, one positive, one negative to get to a negative 15. And then to get to negative 2, I'm going to have a negative 5. So then that's my factor form. The second one is good to go. It's got 1 out front, so all I need is 2 parentheses with my x in it. And I want to multiply to 42, but add to 11, or negative 42 and add to negative 11. And so that's going to be 14 and 3. Right, now to get to a negative 11, I need a negative 14 and a positive 3. Then we did trinomials where A is greater than 1. So we have something different out front. Again, always look for your GCF first, because sometimes you can take that GCF out and it's going to give you a plain Jane trinomial, which is a lot easier to work with. But if we can't, like these two don't have GCFs, we have two options, reverse box and bottoms up. So for the first one, we'll do reverse box. I'm going to make my box. Because it's x squared, I'm going to make it 2 by 2. Okay, my first term goes in the first box, and my last term goes in the bottom right, every time. Then I need to multiply A and C. So I need to multiply 2 times 3 to get 6. Now to find the two boxes here, I need to multiply to get 6, but add to get that middle term 7. And that's going to be 6 and 1. So I'm going to put a 6x and a 1x. Now I have to find my GCF working away from that bottom corner. So my GCF of x and 3 is just 1. There's nothing in common. With 2x squared and 6x is 2x. 2x squared and x is x. And 6x and 3 is 3. And then these are my binomials, so I get 2x plus 1 times x plus 3. All right, for bottoms up, I have to temporarily get rid of that a, so I'm going to take and multiply it by c. So x squared minus x minus 12. Now this becomes my plain Jane trinomial to factor. So I can split into 2 parentheses. I want to multiply to negative 12 and add to negative 1. So I know it's going to have to be 3 and 4. I need my 4 to be negative so that I keep it at a negative 1. Then I have to take that a that I moved over here and take it back out by dividing. I can't simplify 3 over 2, so I'm going to do bottoms up. So 2x plus 3. I can simplify 4 over 2 to get 2. So this one's 2x plus 3 times x minus 2. And the last way we're going to look is a new way. It's called our cube pattern. So it's very similar to difference of squares. Okay, so now I have 2 terms, but instead of being perfect squares, they're perfect cubes, right? Which means something is cubed to get there. Some common ones that you should know. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Those are some very, very common ones that you should be familiar with. Now we're going to use some more later on, but these are the ones that we're going to start with. Alright, so now the difference of the cube pattern is that it can be addition or subtraction. And it's just going to be the same pattern every time. So you're always going to take whatever the cube root is, so in this case a and b, and that's going to be your first parentheses. Then you square the first term, multiply them together, square the second term. And then we have signs to plug in. Well, we have ways of remembering the signs, and that's using SOAP. It's an acronym. Alright, so remember SOAP with your cube pattern. S is for the same sign, O is for the opposite sign, and then always positive. So SOAP. And that's just talking about these signs here. You don't have to think about those. You just put the cube roots in multiply them together, square the second one. And then this one was addition, so it's the same sign, opposite sign, always positive. This one was subtraction, so same sign, opposite sign, always positive. You just have to memorize this pattern. So for our examples, I have 8x cubed and minus 27. And these are both perfect cubes that don't have a GCF. So the cube root of 8 is 2. And then just like with our difference of squares, if your exponent was even, you know it's a perfect square and you cut it in half. If your exponent is a multiple of 3, then it's a perfect cube and you divide it by 3. So 3 divided by 3 is just 1. So my cube root is 2x. And then the cube root of 27 is 3. Ignore the sign. We'll come back to that later. So I'm going to have two parentheses, a short one and a long one. I've got a 2x and a 3. Then I square the first one, so 2x squared is 4x squared. Multiply them together. 2x times 3 is 6x. And then square the second one. 3 squared is 9. Then I'm going to use my signs. So I've got same, so subtraction, opposite, addition, always positive, addition. And that's it for the cube pattern. For this example over here, I have x cubed and y cubed, so those are good. Those are cubics. All right, but 2 and 128 are not. However, there's a GCF. They both have 2 in them, so if I take out a 2, I'm left with x cubed plus 64y cubed. Now, 64 is a perfect cube. So the cube root of x to the third power is just x. And then 64 is 4, and y cubed is y. So I'm going to bring that 2 down. That's part of my answer. And then I have a short parentheses and a long parentheses. Now I have x, 4y. Square the first one, so we get x squared. Multiply them together, 4xy. Square the second one, 16y squared. Then we use SOAP. So I start with addition, so same sign, opposite sign, always positive. And that's the cube pattern. Every time, same sign, opposite sign, always positive.